Hey everybody, we're going to talk about polygons today. So in section 1.4, first is our definition. So a polygon is a closed figure in a plane formed by connecting segments. You can see that here, connecting segments endpoint to endpoint, with each segment intersecting exactly two other segments. So each of these corners or vertices is an intersection with another side. So CD is intersecting with BC and CD is intersecting with ED. So there's two intersections. Each line segment is called a side of the polygon, and each endpoint or intersection is called the vertex. Okay, naming a polygon. List the vertices in consecutive order. You can go in either direction, and you can start with any letter that you'd like. So if you want to name the polygon above, I could just start with letter A if you'd like to. And you can just go around starting A and then B, C, D, E. That is a name of this, in this particular case, the pentagon. Okay, notice there's no commas. You're going in the same direction all the way around in order. Okay, but another example, let's say we started with vertex D. I could go D and then go the other direction, C, B, A, E. That is a perfectly fine name for that polygon. So either direction, start with whatever vertex you would like to. Classifying a polygon. Polygons are classified by the number of sides. See the chart to the right. So all of these are specific names for polygons based on how many sides they have. Many of these you've heard before. Ones that maybe you need to commit to memory are heptagon. That one may be new. Nonagon might be new. And undecagon. Look how that's just one more than a decagon, so 11 sides. Most of these other ones you probably have heard before, but you do need to know all of those. When you get down to n-gon, so that just represents, so if this was 151 sides, then you can simply just call it 151 gon. You don't have to know the name for that. Now, if you're really interested, there is like a website that'll tell you what the specific name of a 151 sided polygon is. You could probably Google it if you care, but obviously we don't want you to memorize that much. But you do need to know these guys. So make sure you have those in your head. Consecutive vertices. Consecutive is one right after the other. Okay, so vertices that share a side. So for example, in this picture, let's look at B and C. So B and C are consecutive vertices because they share side BC, which is a segment. So B, comma, C would be an example of consecutive vertices. Diagonal of a polygon. So a segment that connects two non-consecutive vertices. So two vertices that are not next to each other is a diagonal. So for example, let's say I picked B as my starting point. Well, B to C, those are consecutive. That would be a side. B to A, those are consecutive. That would be a side. So I want to connect non-consecutive sides. So BE would be an example of a diagonal. Okay, next, the convex polygon. So all of the diagonals are in the interior or inside of the polygon. So a convex polygon is what you think of as just a normal polygon. Okay, and if you think about it, if you connected non-consecutive vertices, all of those diagonals are going to be inside the polygon. Okay, so nothing crazy about that, but convex might be a new word for you. Concave. Now that word cave is a really good hint that the polygon caves in. So technically, you have one or more diagonals that are outside of the polygon. But if I took this hexagon here and I started drawing it here and here, but then all of a sudden I had part of it cave in. So 1, 2, 3, 4, 5, and then I connected the 6th. So this caved in part, you call it a concave polygon. Now, the diagonal that's outside would be this one right here. Okay, that is connecting non-consecutive vertices, but the diagonal is outside of the polygon. Okay, definition. So two polygons are congruent if and only if, we'll get to that phrase in a second, if and only if all their corresponding sides and angles are also congruent. So if and only if is a logic phrase. It's actually kind of confusing at first, but all that it means is that the statement will logically work in both directions. So you could have this statement: if polygons are congruent, then all of their corresponding sides and angles are congruent. Or you could also state it the other direction. If all their corresponding sides and angles are congruent, then the polygons are congruent. Definitions are going to work in both directions. Okay, so this is the definition of congruent polygons. Okay, in the example below, if dogs is congruent to cats, and these are just names of polygons, then all four pairs of corresponding sides and angles are congruent. So these are pretty straightforward again. You basically want to look at the actual statement to figure out which are the corresponding sides and vertices. So we'll start with the angles because those are the easiest. So D would go with or corresponds to C. They're the first letters in the names. So you're going to say angle D is congruent to angle C. Okay, so pause the video and do the rest of the angles. Okay, welcome back. So you are also going to have angle O congruent to angle A, and then you're going to have angle G congruent to angle T. Okay, and then I'll start marking them in the picture as well. So angle D is congruent to angle C, angle O is congruent to angle A, and angle G, and you can start making different notations in the corners, is congruent to angle T. Now, you have to be very careful with this pair of angles, because what you cannot do, you cannot say angle S is congruent to angle S. You can't do that because there are multiple angles here and I don't know which angles you're talking about. Okay, so if I want to do this angle and this angle, I'm going to have to use three letters. So you're going to have to use angle DSG is congruent to angle CST. Okay, congruent sides. So again, this should be fairly straightforward. Again, you're just looking at the name. So you would say DO is congruent to CA. Okay, pause the video and do the rest of the segments. So then from there you would say OG is congruent to AT. And again, you can mark the picture as you go. So DO is congruent to CA. OG is congruent to AT. Next, GS is congruent to TS. And then you're going to wrap around the name with SD is congruent to SC. Okay, so the rest of these you have, SD, so 1, 2, 3 there, 1, 2, 3 there, and then 1, 2, 3, 4, and 1, 2, 3, 4. Okay, perimeter. So it's just a reminder, perimeter is just the sum of the lengths of the sides of a polygon. You just add up all the sides. Next, so equilateral. So equa or equal is pretty much in the name. So all the sides are congruent, or you could say all side lengths are equal. So side lengths are equal, and then sides are congruent. You got to keep that stuff straight. Okay, lateral meaning sides. You just draw a polygon that has congruent sides, so like a rhombus, like that. All four sides are congruent. Equiangular, so again, this one's a little easier to identify. Angular, so angles. All the angles are congruent, or all angles have equal measures. Okay, so if you want to do the quadrilateral again, you could do a rectangle. So that would be an equiangular polygon. All of the angles would measure 90 degrees. Regular. So a regular is both equilateral and equiangular. And if you kept with the quadrilateral theme, that would obviously be a square. So you have 4 right angles or 4 90-degree angles and 4 congruent sides, but it needs to be both. Now, all of these polygons that we were requiring you to know the names of do have equilateral versions, equiangular versions, and regular versions. I just did the quadrilaterals though. Okay, next you're going to classify the following polygons as convex or concave based on the picture by the number of sides, so triangle, quadrilateral, hexagon, octagon, whatever it is, or say that it isn't a polygon. So pause and do that. Welcome back. So this guy is going to be convex. It's all just a normal looking one. This one caves in. That one's going to be concave. We'll count the sides here in a second. These two, this one in particular, not a polygon. Polygons has to have all segments. So with that curve there, that is not a polygon. And then this one's interesting. You cannot have crisscross sides. So each side can only intersect with its consecutive sides. So this one is also not a polygon. Okay, so starting to count these, here's 1, 2, 3, 4, 5, 6, 7. So that's a heptagon. Okay, this one has start there. 1, 2, 3, 4, 5, 6. A hexagon. Okay, last 2 examples. So these are algebra. What's really important here is that you read your given information. If you have a statement, a congruency statement, that is super, super helpful. So I have A, B, C, D, E is congruent to Q, R, S, T, U. Those are 2 pentagons. So generally what you want to do is definitely draw those and label them. It really helps solidify what the question is asking, and then label what you are given. So draw the Q, R, S, T, U, and then give that a try. This one is slightly different because you have equilateral polygons, but try those on your own. So pause and try those and then come back. So answers, this is the measure of angle A here is going to be 80 degrees. And then down here, the perimeter, so it's asking for perimeter, actually has 2 answers, 60 or 95. If you didn't get those, please ask to go through them in class. Okay, we'll see you next time.